Alright, our last little bit. We're going to try to graph some functions. So we're going to start with a linear function, right? And all that means is we're looking for this format, y equals mx plus b. We're going to solve for y. Alright, so we're going to graph this function, which even though it doesn't look like it, it is a linear function. You can tell because the x is to the first power, y is also to the first power, right? And in order to do that, we're going to take this, and just like we did literal equations, we're going to solve it for y. So if you subtract x from both sides, right, negative x plus 15, and then we're going to take that, negative x plus 15. We're going to divide the whole thing by 3 in order to get y by itself. And I get y equals negative 1/3 x, 15 divided by 5 plus 5. And there's my equation. So I'm going to write it again. Y equals negative 1/3 x plus 5. Alright. And so we have a linear equation. I'm going to circle it. So they've also told us to graph it over this domain. So it's given us 4 inputs, 4 x values. And if I plug in a 0, right, I've got y equals negative 1/3 0 plus 5. That would give me an output of 5 for a point of 0, 5. Then I could plug in 3, y equals negative 1/3 of 3, which is negative 1, plus 5, which is 4, right? So I have an x value of 3, a y value of 4. If I plug in 6, y equals negative 1/3 of 6, which is negative 2, plus 5, which is 3. So that gives me an ordered pair of 6, my input, and 3, my output, right? Then I plug in 9, negative 1/3 of 9 is negative 3, right? Plus 5 is 2, gives me an input of 9, an output of negative 3. And all we're going to do is graph these, all right? So I'm going to graph 0, 5 right here. All right, I'm going to graph 3, 4 right about here, I believe. Right? Oh, 3, 4 is right there. I'm going to graph 6. 0, 5. I kind of missed 0, 5, and I did my key wrong. Let's do 3, 4 again. So 3, 4 is right here. I went too high. 6, 3 is right here. Right, and this should be 9, 2. 9, 2 is going to be, what, 79, somewhere around there. We can see this is going to form a line right there. So we have taken an equation, we've solved it for y, we've plugged everything in, and we can graph it and we can see our line. Let's keep going a little bit. Alright, that's page 137. Didn't take too long. We'll go 138 here. Alright, page 138. Why did you not connect the points on this graph? Well, for one, we were given, right, the domain. And I think it was 0, 3, 6, 9. Makes this a discrete graph. Discrete graph. They didn't say for all real numbers. They said specifically for 4 points. Let's make sure those are those 4 points. So it was a discrete graph. How would the graph differ if it was from 0 to 9? Well, look at that. Well, I could use all numbers, right? And between 0 and 9. That would make this not a discrete graph, right, but a continuous graph, making a continuous graph. All right, I would then have to fill it in, right? I wouldn't just leave points. All right. So what if we do that? Let's keep going. Let's go to the bottom of this, and it says if the domain is all real numbers, right, like this suggests up here, any number can be used as an input value, producing an infinite number of ordered pairs, right? Arrowheads are drawn on both ends on a smooth line to curve to represent the infinite number of solutions, right? If the domain is not provided, it should be assumed the domain is all real numbers. So here's our steps. So there's notes right here, right? Use the function to generate ordered pairs by choosing several. Plot to see the pattern. Connect the points with a smooth line or a curve. Well, here's an example, right? This is what's called, and you're going to deal with this later on, a quadratic equation. So given my function, if I plug in all these values, I get these outputs here, and we're noticing that the trend here is to make a U-shaped graph, right? So there'll be one for us to do, so let's do one right here. Let's do this one, okay? This guy right here gives us a function of 3x minus 5. So if I plug in points, if I plug in -1, well, 3 times -1 is -3 minus 5 is -8. So -1, -8. If I plug in 0, 3 times 0 is 0 minus 5 is -5. So that's 0, -5. If I plug in 3, 3 minus 5 is -2. Well, I plug in 1, sorry, but that's 3 minus 5 is -2, so that's 1, -2. This one, if I plug in 2, right, 3 times 2 is 6 minus 5 is 1. That gives me 2, 1. This one, if I plug in 3, 3 times 3 is 9 minus 5 is 4, so 3, 4. This one, if I plug in 4, right, 3 times 4 minus 5, that's 12 minus 5, which is 7, so I have 4, 7. Now, plot the points. So let us go ahead and plot these points. I've got -1, 8. I have 0. Oh, -1, -8. Let's do that. -1, -8 is down here. 0, -5 is right here. 1, -2 is right here. Oh, that's 1, -2. Alright, these go by 2, so let's do 2, 1, which is right about here. My scale's a little bit different, right? So let's go back, and then we're going to do our -1, -8, which is actually a little bit further to the right here. Alright, and then my 1, -2 is right here. And we can see that this is going to form a line right now, but let's keep going. Let's do their other ones. So we'll go to 2, 1, and then 3 right in the middle, 4, and that sure appears to be on the line, and then 4, 7, which is right there, and we can see that this forms a line. So I'm going to put arrows on the end, right? I have to get my lead back out. So the point appears to form a line. Draw a line. We're going to continue it, all right, through all the points to show the ordered pairs. All right, and draw arrows on both ends, here and here, to show that it goes on forever. When graphing a function, doesn't matter if the function is written in function notation? Well, that's a really good question. Doesn't matter how I use it when I'm doing this. I would say that it probably doesn't matter. I guess because it doesn't matter how you write it. The inputs and the outputs are the same. So it doesn't matter if I'm using y equals or f of x. Alright, let's hit one more down here. I'm just going to hit a few graphs. Alright, and this is a bit of a long one, but we're going to get through most of this. So let's do this guy. And we're going to plug a few points in. So I'm going to say x and f of x. Well, what if I plug in 0 in? Y equals -0 squared, right? Which gives me y equals 0. Right? If I plug in 0, I get 0. What if I plug in 1? We'll say y equals -1. And that is squared. And this is a tough one because the negative's on the outside of the parentheses, right? I'm going to put parentheses where my x is and square it, which is -1. So if I plug in -1, out comes -1. Let's plug in, oh, that's positive 1, isn't it? I plugged in 1. What if I plug in -1? What if I say, hey, let's plug in -1? Y equals -1 squared. But that negative is still out here, right? So that's negative outside the x with the -1 squared. And the -1 squared makes that negative go away, and this negative drops down, I get -1. Y equals -1. So if I plug in -1, I get -1. So what I'm getting is I'm getting a graph, and I'm going to show it to you right now. Right? My graph is starting to go down, and it's going to end up looking like this right here. So it is actually another parabola, right, that goes in the opposite direction. There is one more here. I'm going to plot a couple points. And you only really need with a linear equation to plot 2 and x and y. So if I plug in a 0, here I go. So if I plug in 0, y equals negative 4 times 0, right? Plus 2, which is 2. What if I plug in 1? Y equals negative 4 times 1 plus 2 gives me negative 2. What if I plug in 2? Y equals negative 4 times 2 plus 2, which gives me negative 6. I can see something happen. So I go to 0, 2, I plot that. There's 0, 2. I go to 1, negative 2, which is right about here. And I go to 2, what do we get? Negative 6, which is right here. And I can already see my line forming right there. And my graph is going to look like that. Alright. So I believe we've gone through at least 3 pages. I'm going to stop here and then I'll come back and talk about this.